I'm going to walk you through this problem from the warm-up for the afternoon sessions from Thursday and Friday. What we're looking for on this question are two things. We're looking for the mean and we're looking for the standard deviation. So if we have two unknowns, then we're really going to need to set up two equations. And this is going to be a throwback to your Algebra 1, Algebra 2 days. So we are going to need a system of equations because we have two unknowns and we're going to set up two equations. The equation that we're going to be basing this whole thing off of, this is just the generic z-score formula. So z is the data value minus the mean over the standard deviation. And what we have, if we look at the problem, so we know that a bumblebee poison dart frog with a length of 33.5 millimeters has a z-score of -1. And we can come up with an equation for that. We get -1 for z if we plug in 33.5 for x. And remember, we're looking for x and we're looking for s. We're looking for the mean and the standard deviation. We can do the same thing with this information. 38 millimeters has a z-score of 2. So if we plug in 38 for x, we are going to get 2 for z. So here we have a system of equations. We have two unknowns. We have two equations. I can rewrite my equations. I don't love having the fractions here. I can take that top equation and multiply both sides by s. So this would turn into -1 times s. So negative s equals 33.5 minus x bar. If I do the same thing for the other equation, I would have 2s equals 38 minus x bar. So here's my little system of equations that I need to solve. To solve this, I decided to do it with substitution. I took the top equation and I isolated the x bar and I plugged it into the second equation. There's a number of ways to do this. You could just isolate the s and plug it into the other equation. You could do elimination. Maybe you multiply one of the equations by -1 and you add them together. But however you want to do it, you have a number of different ways you can approach this problem. So if I isolate that x bar, I would have x bar equals 33.5 plus s. And what I did with that is I plugged that 33.5 plus s into the second equation for x bar. So what that would look like would be 2s equals 38 minus 33.5 plus s. And now we have something that we can solve. 38 minus 33.5, just be careful with distributing a negative. If I move that minus s over to the right, I would have 3s equals 4.5 and s equals 1.5. Once we know what s is 1.5 millimeters. We can plug that back into this expression all the way up here. So I know x bar is 33.5 plus s, so I'm going to have plus 1.5. So x bar is 35 millimeters.